Okay, well, good here. Everybody ready? I need to check something here. Brandon Chuang from Acton. Is he here? Is anyone from Acton here? You, Brandon? Nice to meet you. Brandon's been helping me with the driver work, so I just wanted to find out. Go ahead and have a seat, but come on up front. Or kind of good seat. So let me start this out. I happen to have on my laptop, there's always the OOM demo. So let me just show you briefly what we're doing with OOM. This isn't actually something we sell, or this is our trade show demo. But OOM basically is access to the optical data, right, that I mentioned on the EEPROMs. And with that, I like the screen much better. With that, we can do things like you can show on a device the temperature, voltage, laser bias, receive power, transmit power, live for QSFP device. This isn't live, obviously, because I'm not connected to a switch, but this is the kind of stuff we show. And by getting all the data out of the QSFP, I can not only show the temperature, which OOM provides as a floating point number, the voltage floating point. It actually does dBMs and so on. All that calculation comes from OOM. But I can also fill in the alarm and warning levels, so you get red zone, yellow zone, green zone. This data, for instance, is on page 3 of the QSFP EEPROM, which is why I need that data. Without that data, I can't tell if we're hot or too hot or too cold. I can just tell what the temperature is. So that's the kind of thing that we're doing, that we want these drivers to be better for. So let's just fill the screen here. I have a couple pages of getting us started, then a bunch of questions, topics to work on, which we can add more and make this interactive real soon. Oh, I probably did this to myself. So first of all, like I said, OOM's a Python package. If anybody's excited about this, says my product needs this, but it has to be in C because that's how we think, let me know. Let's talk about it, because we could do it in C as well. But right now it's Python, because we expect the data center operators are using Python to do their high-level scripts to manage their data centers. It's EEPROM data encoded and decoded in key value pairs. So we'll show you what that means here in a second. It's one API for any Linux-based NOS, any switch, any module vendor, any module type, right? This is not a Finisar product. What you'll find on GitHub doesn't have any Finisar special stuff in it. However, it has a provision to add proprietary stuff that's documented that anybody could use, and we show off some special Finisar things using the proprietary add-on interface, but anyone else could do that as well. It's open source, easy to maintain, easy to extend. It's on GitHub. It's up and running now. The idea is you import a Python package, you get a list of ports, so that'll be a list, a Python list, and you basically ask for get memory, get me the DOM memory. So DOM is the digital optical monitoring. That is its voltage, temperature, transmit, receive power, and bias. One of the things built into OOM is get me the DOM data. That's a keyword in OOM. And out you can print out the port you got. So for that port, it's got a name, and just turn that status into a string. It's a dictionary, and you get this. In other words, there's a key VCC. You ask for VCC, you'll get a number, temperature, power, and so on. The idea is that's simple, and that'll run on any switch, any NOS. Just boom, away it goes. Okay? That's what we're aiming for. It actually works on several different NOSes and several different switches right now. We've been showing this at trade shows now for a couple of years. All right. The architecture is really simple. The driver provides access to the EEPROM. We decode it with a table of this key is found at this location, it's this long, here's the decoder for it, and back comes the data. It also does writes using the same keys and locations. It'll encode the data and write data to the EEPROM for appropriate keys like transmit, disable. So moving to the driver, what I need in that driver to do what I just described, I have to be able to read and write. So surveying the drivers I have seen, I haven't seen anywhere near all of them, but we're just talking about SFP, QSFP, EEPROM drivers. Many of them don't write. And if they don't write, I can't control the device. I can only read from it. Needs multiple I2C addresses. So SFP actually uses 2 I2C addresses for its address space. Multiple pages. I need to get up to the architected limit. So right now the QSFP spec says it goes up to page 3. It's obvious. I mean, the page table, the page select is 127 choice. I mean, it's 8 bits. So you could have 128 pages, but right now the spec says there's 3 pages, and the drivers I've seen, some of them only go to page 3. I need to get past that. I'll explain why in a minute. So as not a must, but high priority, I'd like to eliminate an internal read-write buffer. Many of the drivers have a buffer in the driver that is trying to, for instance, cache the data, which is kind of dangerous because some of that data, like temperature, should be dynamic. And if you try to cache everything, that's 16,000 bytes of data that's mostly not going to be used. It's going to be stored for every single device. We can just do a read-write straight through it. And I'd like to have one driver for both SFP and QSFP. Right now, there's 2 of them, for instance, in some of the NOSes. And it's not that hard to do the mapping. And we have a driver that does this. That is, I've written a driver, run it under a couple of NOSes that does all of these things. I checked it in just 2 days ago on the OOM site. That'd be a good place to put it for our discussions, so you can look at it later. So that's what I would like to get out in the world, everybody using, all the OCP networking NOSes running so that I can do all this stuff I'm trying to do, mostly so that optic vendors can get their data to our customers. That's the bottom line. We're trying to get that data to our customers. If the driver doesn't access all those pages, if the driver doesn't do right, the customer can't do anything. OOM can't do anything. Okay? Yeah.
So how much of you said the data goes to the NOS. How much of that data that DOM information is forwarded outside the switch?
How much of that is forwarded outside, how much of that data is forwarded outside the switch? I have to ask, when? I mean, the OOM has there's a module in OOM that will export it as, I don't remember the form, over the network. So I can actually run this over the network.
Sure. So I'm just thinking of your traditional hardware management where, similar information is extracted from a server or network switch to, hardware management tools, right?
Yeah.
Power consumption, temperatures, inlet air, things like that.
Yeah, exactly like that.
Right. So is the DOM information also sent on to a rack manager or some type of pod manager? Or?
Not yet. We'd like it to be.
Okay, so that was my question. You think that's the target?
That's exactly what we want.
Of the data.
Yes, exactly.
Okay, so today through DTMF we have IPMI as a protocol to forward that. Right, there's a lot of work going on with Redfish to create a new and updated version. Right? Do you envision that this becomes part of Redfish, or Redfish extensions work with this API?
Yeah, okay, so for anybody on the network, the question is, how does this data get off the switch and into the data center operator's management console, like Redfish, for instance? So we started out, the very earliest version of this, we were aiming for a network interface and making it available externally. We started with just do the decode function, and we'd see if there was demand for putting it over the network. Nobody has stepped up and said, I really, really want that, but it's a good idea, it's available. Everybody's got a different favorite way of delivering it, so we were focused on making it easy to access. So if you want to plug it into Redfish, you could call OOM and get all that data and plug it in without having to do the decode part yourself. We don't have a transport mechanism defined. There is an example of how to do it on the GitHub site. We run all our demos off the laptop, runs over the network to a switch. So it's easy to put it onto a protocol of your choice. We didn't do that. Could be done.
Is it no one's asked for that because they don't know about it?
Probably.
Okay. So the DTMF organization, specifically John Leong, who chairs the Redfish working group, has made a proposal to OCP to create an OCP profile for servers. And that's the initial proposal, but it would extend
Yes, yes, I agree. So for the folks online, we're typing in the question. So I'll just start gathering questions here and making up some slides. Other possibilities, remind me the name of the one we were working with, the network running up in San Francisco.
There's a local San Francisco.
The transport was S-Flow. S-Flow, that's it. S-Flow we've talked about. A REST interface. I mean, half a dozen OS NOSes here have their favorite REST interface to export the one true API to access all this stuff. You know, those would also be good candidates for where to put this. And anybody who actually wants to do that, my time is available to make it really easy to help you get this data into your favorite protocol. Yeah.
Redfish people presented data model 1 or 2 ATFs ago. Are you going to work with them to include optics?
I haven't got plans to do that. I probably should.
But they're covering Ethernet.
Sorry?
They're covering networking parts as well.
Okay, okay.
It's mostly Dell people, I believe. David Black.
Oh, Dell. Okay, all right, got it.
Maybe more question for everyone, but like, can you compare this to something that's done on a server? Like, just mentioned like voltage and temperature monitoring for a server. How do you see the optics being any different from that? Like, why would we need a different solution for optics in terms of monitoring then?
Okay, so the question is, why do we need a different solution for monitoring optics than everything else in a...
I'm talking more about the transport and the schema for like
Right.
voltage and temperature and things like that.
Right, so for transport, for the schemas and so on, I don't think we do. Our goal was to get optical data into that mix. And we started it with, how do you decode the thing? How do you get it and decode it? So yeah, the whole transport question is an excellent next step that we just haven't started on yet.
It might be nice when you have the audience to kind of collect the top 3, you know, that everyone's using in their data centers.
Okay. So Dustin says, how about identifying the top 3 protocols and formats and... Okay, so Dustin, what's your favorite?
Like graphite, carbon, collect D. Just say collect D. Anyone who's collecting.
Okay, so he says, how about collect D, which shameless plug for OOM and what's on the GitHub site. There is a collect D daemon checked in up there because Dustin did it a year and a half ago for us. Thank you. So collect D and Grafana and those guys. Anybody else have a favorite protocol? So I got obviously Redfish. Any other standards, anything OCP is working on, server side? Anybody have a suggestion for other ways that this data should be exposed outside the switch? Yeah.
If you do YAML, it should be netconf and gRPC.
Sorry?
If you do YAML, it should be netconf and gRPC. So gRPC would be preferred way.
Okay, I'm not familiar with that, so I may not have heard you correctly. gRPC.
Used by most vendors for streaming television.
Okay. All right, so our topic is the driver. This is very useful, thank you. But back to the driver, because none of this will work if we can't get the data out of the NOS. Okay, where are we at? Okay, so why that list of requirements? Why do I need more pages? What do I need to write? So right now, for instance, I described the QSFP alarm and warning thresholds. So these actual values, the alarm and warning thresholds, which allow me to draw the red, yellow, green bars, those are on page 3. If you can't get to page 3, you can't get that data. All you can tell is what the temperature is. Sometimes I need to be able to do a write, for instance, the transmit and disable. Finisar has a very cool feature called connectivity diagnostics that we're showing to some customers where you can, like I said before, automatically trigger the pull tab to light up so that from the data center you can say to the guy out on the floor, or from the management center you can say to the guy out on the floor, I'm working on port 17, that is this one, and the light will actually start flashing on port 17. And he says, now make sure it's connected to the right server, and the light will be flashing on the server too that's connected to it, right? So both ends will flash. To do that, I have to be able to write to that device saying, turn on the light flashing, and then write again to say, turn off the light flashing. A lot of drivers that are out there don't allow me to do write. And actually, to do this, I need both because the pages that control that are not on, they're page 1 or 2 or something like that. Future features, we have a really interesting capability to reach out to the remote device at the other end of the wire and get the data from it, all the data from it. We're showing that to some customers. To do that, I obviously need access to more pages, and I also need to be able to write to give the command and then read the data that came back. And much more basic QSFP-DD, the next generation 8-port optics. If you know how the EEPROM is laid out, you know there's no space to provide all this data for 4 more ports. We're going to use more pages to put that data on. It's not in the spec yet, but it's going to be. So I need a driver that gets to all that available space. Any questions so far? What we're trying to accomplish?
We're talking mostly about reading data. Are there tunable SFPs, and can you use DOM-type mechanisms to change the wavelength?
Yes.
I brought my Finisar expert. They hired me for the software stuff. He's the actual, the guy that knows the optics. Yes. Oh, by the way, just a little plug for OOM. CFP support is now also in OOM. If anybody can show me a switch plus NOS that supports CFP, I would love to try running my code. It's only on a simulator now, but it actually, you notice there's a simulated CFP port here that I actually have a total of 4 keys. Identifier, voltage, temperature, vendor name, just code it up. But basically, CFP supports here too, just because you were asking about different types. All right, so now I want to go to,
Is C Cisco?
no, CFP is,
Compact.
you want to explain?
Well, it's where the 100 gig interfaces started, and we couldn't put them in the size of a QSFP. So it's designed for a larger, more complicated format.
It has a completely different layout in the EEPROM. It's accessed by MDIO, not I2C, so we're going to need a new driver, but OOM just says, where's it at? How do I decode it? Let me provide it for you. So the same simple interface can basically go through all the plumbing and get the data for you. So I wanted to just make sure, since we're going to get gritty in the driver, make sure we're clear on how the memory is laid out. So basically, what OOM is going to look for is a file in the /sys file system that represents the EEPROM as a flat address space from 0 to hopefully over 16K. The way it's laid out in the spec, SFP has a I2C address A0, 128 bytes, followed by another 128. A2, it's got 128 bytes, and then it's got a pageable section at the second half of A2. And these pages go on to, well, it's 8 bits, so in theory there could be 128 pages, and in fact the spec indicates that there could be that many. Okay, we're going to lay this out as a linear address space like that. Okay, that's what the driver's job is. One of the main things its job is, when you say I want D, it's going to say, oh, you mean I2C address A2, you want page 0, put that in the select register and read it out. Okay. For QSFP, it's different. It only uses I2C address A0, followed by pages. The spec only shows these 4 pages. We want to go farther. It's the same 8-bit address space, so we could go further. There's more pages. I have prototype devices at Finisar that use them, but the architecture or the spec doesn't say they exist. So once again, we're going to lay those out. So one of the things we want in the driver, if it's going to work for both, is it knows which type it is, and it will take a linear address and turn it into the right I2C address and the right page and the right offset. Okay, I'm just about done preaching. Whoa, where am I? So we did that. That's why we want it. So here's some things I brought to talk about. As I talk through these briefly, I want to know which ones we want to work on or what other things you want to work on. And we'll write down additional stuff if it's there. So I have a driver that nobody's using that does all the stuff I want. All right? Not very interesting. I've discovered that different NOSes expose this data at different places in sysfs, right? So what attributes to expose? Some drivers look inside the EEPROM and will give you various bits of that data from the driver directly in sysfs. What names for those attributes? They have different names. ONL uses, Steve not here? Steve chose a different place, okay. ONL calls them SFP under EEPROM, and I think Cumulus calls it just EEPROM or something like that. They're all different, and it's built into the NOS. I think it would be interesting to consider whether we can standardize on the names. What directory do they go in? It turns out those are different. This is where Cumulus puts them. One of the places Cumulus puts them. They put in a couple places. There's a sysfs buffer limit of 4 KB. I now have 16 KB of data I want to get at. So we probably need to check and make sure that doesn't get overrun. Configuration. I have been puzzled and confused by figuring out how the ports are mapped to the names. The driver doesn't want to know. The driver just wants to say, I got a call from sysfs asking for data, here it is. But somehow we got to know what port it's on. So I'd like to think about figuring out how that's done and whether we can standardize it across NOSes. Which ports use which driver? Right now, there's the AT24 driver and the SFF8436 driver for SFP and QSFP. So when you configure the system, you got to know which one it is unless you use just one driver, in which case the driver needs to know what kind of device it is. So I need the dev ID values. Hopefully I haven't lost everybody yet because this is the nitty-gritty stuff we need to work on. How big is the EEPROM, right? The driver would like to be able to say, you just asked for something out of range. To do that, it has to know how big the EEPROM is. Now there's a bit in the spec that tells you whether or not it's paged, but that doesn't tell you how many pages it has. So maybe I need to work with the spec people to get that extended. Or maybe I can make it part of the dev ID value, how big it's going to be. Or maybe we can just make it unlimited. And you get what you get when you actually do the write or the read. So do I configure it? Do I make it an sysfs attribute that we could modify? Do we just go for the architected limit and say it's 16K plus? I think I got 2 more pages of these. Interrupt handling. So at any time, those things can be pulled out and put back in, right? So when they are, I need to know that so that I can, for instance, it might be a different number of pages this thing handles. Basically, one driver I looked at checks the presence on every device access. Do I have to read the pageable register every time I read it? Do I have to read the pageable register, then write the page register, then read the data I want? Or can I skip at least reading that pageable register, assuming it didn't change? Well, if I can get an interrupt when the thing is inserted or removed, I can look just once for any data that can be cached. The drivers have 4 different ways to access the data, and I'm not sure that this is clearly derived from a driver that's derived from a driver that's derived from a driver that goes back to the PC days. I don't know if I need all that stuff, but I'm not expert enough, so if anybody knows, it'd be great to understand that. How do we handle failures, error, or retry? Right now, one driver retries, others just error. Just a placeholder. CFP driver, MDIO is presumably a different driver because it's going to go over a different MDIO bus. It accesses different devices. It's not paged. It's a pretty different beast, so just FYI. And finally, who wants to help with this? Who wants to help with development? I've been doing development. Brandon's been doing development. So you don't have to. Please engage. You don't have to do the development part, but if you want to, I'm very interested. Who can help us review the code? In particular, who can test it? I've got 2 switches, both the same kind, which limits my ability to test, but I would love to get someone engaged in actually using this driver in production, which would mean run it through a whole bunch of different QA processes. I'm standing behind it. I'll support it. I'll help fix the bugs. It's not very complicated, but I don't have the resources to run a test program. Where should we put the reference copy? If we got one we love, one driver that everybody's going to use, where should it go? I have checked the one I have into GitHub, so anybody can look at it, check it out, tear it apart, mangle it, use it how you want. Please talk to me when you do that because I'm passionate about it. And most important, who's going to adopt this thing? And how does that happen? Cumulus seems to write their own driver. It looks like ONL adopts the driver that Acton writes. So I'm working with Brandon to get the Acton driver to do all this stuff, and hopefully that flows into ONL. And I'm not clear on what other NOSes do. So these are the questions I would like some help with. Probably most important. Anybody who says, I'm in, I'll adopt that driver, you get, first pick and second pick and third pick. That's it. That's as far as I get. Any more topics? Anybody here going to say, I have a NOS that needs that? You all thought this would be a great session. So tell me what you came to hear, or to find out, or to help with.
So initially, when you had that dashboard where it shows the various parameters, the red, yellow.
Yep.
Is that open source also, or?
No. So the question was, is the demo open source? And the answer is no. I wrote that to show off OOM, to go to trade shows. It's kind of gnarly and I'm not proud of it. I'm not a GUI writer, but I managed to hammer this out and make it work. So no. Would that help? Would you adopt OOM or the driver if I made this available?
Well, it kind of shows up the capability of what this OOM can do, right?
Mm-hmm.
So I would say it's a good demo kit.
Is it just not open source now, or is it not available as like a binary type installable package at all?
It's just a bunch of Python files in my home directory at home. It could be made. There's some stuff in it that I can't share because Finisar proprietary, but I can leave those pieces out.
I think it would be very helpful to give it to the customers because, at Edgecore we ship OOM on all our products with ONL. So there's a lot of eyeballs that would be able to view that piece you have there and understand why that information, if they don't already understand why it's important to them. So I think that would be good to make that available. It doesn't have to be available as source, it could be available as an installable type of, an application or something.
Well, it's Python, so it's pretty hard to hide what's in there. And I wouldn't want to anyway. I mean, yeah, that's a good idea. I could do that. What else?
So is your application detecting pluggables being inserted, removed? Is it monitoring for events on that, or just that?
Good question. The question is, does my application monitor for plug in, unplug, remove? Does it monitor for events? The answer is no. I don't have an interface that I know of that would tell me that. So that's why I think I had on the list of driver things, can we get interrupts, including to user space? So, I would need to, the driver would need to know that happened, which I don't see evidence that the drivers I have do that. I mean, they just try to read and write, and if it doesn't work, you get a failure back. So I would love to get an interrupt that says it's been inserted. I assume the hardware allows that, but I'm not sure. If anybody knows, that's what we're here for.
Next question, what's up?
Most of the SFP cages have a presence pin, which will generate an interrupt.
There's a presence pin. You can test for presence. Will that generate an interrupt?
Most of the switch platforms do CBLD, and then the CBLD waits changes, which usually the way it works.
Okay. So there is electrically a way to do that. We need to plumb the software. But not having that, no, the OOM does not have any interrupt capability at all. It doesn't know, there's no interface for interrupts. It's been on the list from day one. I've discussed it with Dustin a year and a half ago, and we said, yeah, that would be complicated. That's as far as we got. Yeah?
So I can see a lot of traffic going on I2C. Have you considered the clock stretching, and what is the speed for the digital monitoring?
It is not fast. So the question was, I2C isn't very fast. I got a lot of devices on there. Basically, how long does it take? Is it slow? What are the implications? Off the top of my head, I don't remember, but we're talking half a second to scan all the devices. I mean, we're not talking microseconds. Many milliseconds. It might be 15, 20 milliseconds per access per device. So it's not fast. On the other hand, there's not much other traffic going on that bus. I mean, actually, each one is an isolated bus between the CPLD and the module. So each one is actually, they all have the same address. They're all at I2C address 50, or A0. So there's not a lot of traffic to that. But anyway, I don't think there's a problem with the system being bogged down, but there is a problem with just the amount of bandwidth available through those buses to get the data out of the system. So you can't monitor every tenth of a second. I have run this demo at a 3 second. Every 3 seconds it'll update the data and haven't had a problem. It takes about a second, 2 seconds just to inventory all the ports on a 54 port switch. I have to access them all once and then access them all again. So it's like 2 accesses in a couple of seconds through everything. So it's not fast. But you know, if you're monitoring and you want to get data out every 5 minutes, it's just fine. Any driver writers here? Anybody want to help me write a driver?
So Don, you've tried to make a case for needing a new driver. And you've kind of earmarked the fact that there are these new modules coming on board with 8 channels instead of 4.
Okay. Mm-hmm.
I think those will go to the typical OCP switch pretty fast. It'll be timed by the next driver, switch interface chipset. So it could be as little as a year. In the scale of things, it'll take us a year to write a driver. So I would be interested in polling the audience. How many people think we've made the case for a new driver is being needed?
Okay, so for the folks online again, Steve asks, how many people think we do need a new driver? In particular, QSF PDD is probably going to be available within a year. Plus these other things, do we need a new driver? Hands up.
I might add that there's another competing mechanical interface called OSFP for octal SFP. And we don't know which one's going to become popular between QSFP, DD, or OSFP. So some people in the room may be going towards OSFP, but we're not trying to exclude.
But either one will be basically I2C, paged, has exactly this set of questions and issues.
Will QSFP DD slots take QSFP SFPs?
No.
I like it.
Yes? Okay. All right.
Octo slot will take a 4-way.
Okay.
Yeah.
All right.
Oh.
So go with Jeff's.
Wait. You said an octal slot will take a 4-way. Will a 4-way slot take an octal? Okay.
I don't believe that's the case. But
So yes and no. Yes and no is your answer, and they're both right.
Well, I think that colors whether you need a new driver and a new interface or not.
Well, if you're going to use the new device and want this kind of data, you have to have a new driver. The old driver will give you some data, but it'll tell you the first 4 ports probably, but not the other 4 ports, because they're up at a page you can't get at with the driver.
If you don't know ahead of time which kind of device is going to be plugged into the socket, then it seems like you want to have one driver that can cover them all.
Oh, absolutely. Yeah. So Steve's question, let me just get hands. Who thinks we need a driver or need to solve this problem one way or another? I got yes. Come on, Dustin. We got to get to more pages. Anybody else? Okay, we got one guy convinced.
No, I think we need. I mean,
Okay.
we have, just from our point of view, EdgeCore, we have customers that are using OLM today, and they're using it with whatever application. I don't know what they use to mine that data and pump that up to their collection system. So we have customers that are actively using this. They're eventually going to go to DD-based products or OSFP, whatever wins for that. And they also have the need to do other modules like XFPs in a same type of device. So we have an OLT platform that has QSFP 28s and XFPs.
Okay.
Same device. So we would need a driver that, I don't know what an XFP has for interface. If it's I2C and
I
page,
think, isn't that the one we talked about online? XFP, I believe, is an I2C and paged.
Okay.
Yeah.
I mean, so we
So we need to test it, but I think it should work.
We have the need to support customers that are using OLM today, and so we need to make a driver that will support this going forward.
Perfect, which is why Brandon is working on it. So just so you know, that's EdgeCore is working with me on. We've swapped code and have a driver that works, that Brandon has that does all this stuff. It has all the capabilities we need on the first list. So the question of sysfs and interrupts and all that's still open, but a basic driver that allows us to do all this stuff, EdgeCore has, and we're working on figuring out how to make it production quality and get it into use, and especially get it across all the platforms. I believe it's just a 7712 driver right now. So
So I guess, eventually if that driver becomes open source, would other, supplier be able to use that? Or, well, obviously we have to tweak it.
yeah, so the question is,
Work with different type of I2C models.
yeah, so the question is, I now heard two. Alpha asks, basically, can we use it too if EdgeCore has developed it, and does it work for different I2C topologies? So let me take this one at a time. The first I find more interesting. Your driver goes to people like ONL who put it out as open source. I believe it's an open source driver, right? Which means other people can use it.
We have no desire to keep that driver specific to us.
Okay.
It's specific to our I2C implementation, obviously.
Yeah, so the answer from EdgeCore is it's not proprietary, it's open source. In fact, I got my copy of it from the ONL open source repository, and that's intended. So it's accessible, it's available. The code that I have in the driver I checked in actually is almost identical. It's derived from the Cumulus. Brandon basically mangled it into fit the format that Acton uses, and I worked with him on that. So the same code. The key thing you have is there's a decoder that will map the address you want, map the address to where you're looking for, and a thing that says, is that a legal address? And it allows multiple pages, and the right code is in it. That can be lifted and put into almost any driver. The actual I2C layout, this code I have doesn't know and doesn't care. Right? It gets a call from sysfs, says, here's the port to work on, and away it goes using that port. It doesn't know how I2C got laid out. It calls the standard Linux I2C drivers to do that. So the whole question of how you do configuration and layout and sysfs, that set of questions I have, they're different, and I don't know how to get them together. I haven't studied it enough, and I don't have a proposal, and everybody's got different code. But the actual things we care about to be able to read and write those EEPROMs is completely independent of the topology and the configuration and the names and so on. That's the code I would really want to get used by everyone. So it might be that I can help you pull the important parts out and put it into your driver. I'd be happy to do that. It might be you can, converge on a standard common way of configuring and naming these devices, in which case we'd all be better off.
Well, I think our driver is pretty similar to what you see on the ONL.
Did you tell me you used the Sonic? You got it from Sonic? So I think Sonic's actually is based on Cumulus's. I recognize that's where I first got the Cumulus driver before I went and asked for it directly. So there's not very many different variations here.
Well, I have a comment/question. It seems like the best way to get it into the hands of the most vendors and customers, especially if you care about servers with NICs in them, would be to make this driver part of the Linux kernel mainline source code. And then there's no question about, are there any licensing ambiguities? Is it standardized by definition? It is on something like the kernel. We can answer a lot of those questions all at once by doing that. So have you thought about that? And what are your thoughts on making it part of the Linux kernel proper?
It's already in sysfs. It's pretty much in the Linux kernel.
No, it's just a module. Right?
It's a module that's compiled for and right. So yeah, it's in the kernel, but it's not in the mainline upstream kernel. Great idea. I have discovered in the year and a half I've been working on OOM that there are those things that are obvious how to do and those things that I'm scared of. And over time I've gotten to, like, writing drivers was on that list, and now it's on the I'm good at it list. Putting it into the Linux mainstream, I haven't attacked yet. So I think that's a great idea. I would expect I need to understand at least and perhaps standardize configuration in sysfs and so on to do that. And I got to get outside of just the read and write EEPROM to do that. So that's what I'm here to ask for some help on. Do you want to help? I'd love it.
SysFS and I2C drivers, maybe I can help you.
Okay,
Mahesh,
from,
Cisco.
okay. Surely others can too. I mean, there's got to be people here that do this stuff. Can we, where am I at? I need to go up. Since it's my session, can you give me a hint on where we'd start here? Is there a standard for what sysfs attributes you think ought to be used? Or how would you go about getting there?
So typically you have this read, right? SysFS, you would have a read address, write address.
Right? So basically, I already have a file called sys bus I2C devices port EEPROM. And I can open and close, I can read and write that device, and the driver is attached to it. That I got. Only problem is, some people call it /EEPROM, and some people call it or SFP underscore EEPROM, and some people export.
How do you know which one goes with which port?
Yeah, it depends upon, some may have it accessed as MDIO, in which case they would put it in a different subsystem.
Right. So I'm going to save MDIO as a different problem. These are all I2C devices. So I expect they're probably all going to be under sysbus I2C devices.
Yes.
So,
That particular device address, that's where it would land.
right. So sysbus I2C devices, and then there'll be a name. Now, I sort of don't care what the name is. You can call that port anything you want, but then I need to know, there's actually two things OOM needs to know, and that is what's the name of the file, the EEPROM file that I can open to read and write. We got to pick one name. Does anybody care? Can I just pick one and just plug it in? And it gets chosen in different places in different drivers. It's like system configuration driver, or different drivers do it in different places. And I need to know the name of the port, which I have two different choices for where to find the name of the port. My favorite, the one switch I have, the number 0 port is called port 1, just to make it confusing. And 48, 49, 50, 51, 49 to 54 are actually apparently 51, 52, 49, 48. They're scrambled. It's confusing.
Yeah, it's something to do with, it might be a sparse register, so they would have implemented it like that. I can look at the code and maybe help you.
Okay, all right. Anybody else? Questions on any part of OOM? In particular, anybody know specifically good ideas for how to get the size of the EEPROM, for instance? Dustin, you're a Linux guy. Would you prefer an attribute in sysfs? Should I just write beyond read and write to the architected limit and let a failure, an error propagate to the user?
If the information in there is standardized, isn't the size known just based on?
The standard says there's only 4 pages on QSFP. I need to go past that. Most devices don't support that. So what do I do if I try to access page 11 of a normal QSFP device? Should sysfs prevent that because I told sysfs how big it was, in which case how did I find out? Should the driver stop that because it knows more than sysfs, but does it? There's no actual thing beyond the pageable bit, and that doesn't tell me if I can get to 3 or 11. Apparently with sysfs, I can give it no size at all. I can specify no size, and it just says, okay, I'll do whatever you want. Or I could have a sysfs attribute that I could configure, but then I got to be able to write it. I got to decide what the value is and write it in there. And anybody else with an opinion, feel free. But this is just one of the silly little things I got to figure out in the driver.
So the problem is you're using it as an EEPROM, which is a flat memory, whereas
Yeah.
what you are doing is at the end of it there are pages, and the page selector selects the page.
Yeah, but that works. The driver handles that. The driver goes all the way to the end of the pages.
But
That-
it's implemented, it's shown to the Linux system as an EEPROM, which is a flat memory.
yeah, which it should be.
But then in your in the sysfs, under that same class where the EEPROM file is, right, you can have other attribute file where
Yes.
you can describe what this EEPROM has, right?
Yes.
That's one way of saying you go.
Yep.
There's a page file which is say 5 or 10, right?
Yes.
Then you can negotiate the application. You can negotiate that number and then come up with okay. Now I can access page 5.
Well, if the application can figure it out, why bother putting it in the driver at all? Just let the application.
It's different pluggable, right? You plug Finisar, it's page 4. You plug another vendor, it's going to be another, they support 10 page.
Right. Nothing in the system, hardware or software, can figure out what that is. Right now, the spec for these devices for QSFP says the spec says page 3 is the last page. The architecture allows more. I want to get at more.
You have to decide what that file represents. Does it represent the full address space that's addressable physically for the device? In which case, I think it should be a 64K large file. And it doesn't care about what you're reading and writing, but that's problematic. I don't know of any other like arbitrary read and write file sysfs.
The way it's being used, it looks like it's implementing an EEPROM, which is typically a flat memory. So it has a fixed size.
Did I get rid of a page? Looks like my QSFP page is gone. I wouldn't guess I intended to change anything, but oh well, we'll use SFP instead. Assuming the same thing, but so I didn't follow.
You have to decide what the sysfs file represents, and if it's just a big flat memory map of all potential pages, then you've answered your question. It should be 64K long, and it should arbitrarily pass through reads and writes to that device at any address in 64K.
Okay, so that is what I think it is. It's
What is that the spec on that? And if you want to support that concept, then yeah, you just make it huge.
okay. So I have one suggestion that says just go ahead and implement all 16K plus bytes, and if the user tries to access page G and the device itself doesn't support it, you just get an error back. Or you get zeros. But the spec actually says for SFP you get zeros back. Is that okay? We comfortable with that? It's always full size and you just get back like zeros? I'm fine with that. That's easy, and I think as the OM guy, that's what I expect. I know what I'm after, and if it's, if it doesn't come back, well, I'll handle it. Yeah.
Is it a principle that all pages should be accessible, or would you conceive of keeping some still reserved? I mean, that more than 3 pages would be available now, but maybe not necessarily all 128. Would there be a use case like that? Or certainly there might be cases where you want to avoid writing, but that's a different issue.
So the question is, might I want more than 3 but less than 128?
Just asking, right? I mean,
Well, if the device doesn't support more than 10, I might want to limit it to 10. I really like the idea actually that there should be a something in the spec that tells me how many pages this device supports, and I'll work with my Finisar guys, and if we can get that in the spec, I'd certainly put that in the driver. It's easy to do. I know exactly where to put it in the driver, but right now I want to go pages past the spec, and there's no place to. It only says pageable or not. So, in terms of limiting access, there are pages that are password protected, and you're going to get an error back when you read those.
so those will show up in that flat file, but they'll just not be readable, right? It'll show up and somehow.
I think it'll return zeros, because the driver will call the device, and the device will say, the spec says the device gives back zeros, I think, for that stuff. That sound right, Steve? Yeah. Okay, got one. We're going to call it one flat address space all the way to 16 plus K and make it accessible as such, and the application is going to decide what to do if it gets back nonsensical data.
We
Yay!
don't know how, like, you know, whether I read it as a 0 or unsupported. Basically, we can't differentiate it.
Because I can't tell. I mean, the device itself is the only thing that knows, and I have no way to ask it.
Yeah, the vendor specific information could be used to figure out, right?
Maybe.
If it's, say, Finisar, we know so many pages of it. Somebody else.
Yeah. The funny thing is, it may depend on the ROM version of the part number. In theory, I suppose a very sophisticated application could know, but that's going to be an awful lot of data, very dynamic data that changes over time in the marketplace. Okay. Where did my QSFP page go? That's just really weird. All right, what else can we do? Anybody else have a favorite question or a different one we should look into? Does anybody know how exactly the configuration process works? I think Kurt wrote the platform driver here in Cumulus, and he's not here to ask. If anybody knows how Linux maps specific drivers with their dev IDs, which is a characteristic that the driver gets passed when it configures, I could use that information to get me offline, whatever.
Tell you how much time you want to take.
I2C is as simple as the bus number you are on. And you said there's a fixed slave address.
Yes.
That's what you will say. If you are on bus number 5, you will be always on the bus.
Yes.
pressing 5.
Yes, but there's a parameter called dev ID, which gets passed when you probe when the driver probes the device. So it basically, the probe call says, here's the device, and here's a magic cookie that tells you about it. And that magic cookie tells you things that only the driver knows what to expect, and they're coded up specially in the configuration process. It might tell you how big it is. It might tell you if it's SFP versus QSFP. It might tell you its port. Could tell you anything. And
It comes from one of two places. Either it's hard-coded by someone who wrote a module or a piece of code somewhere else in the driver, somewhere else in the kernel, a platform-specific piece of code. So you would find it instantiating client I2C client devices one by one with the appropriate dev IDs. So it's something hard-coded. That's one answer. The other answer is it comes from something like open firmware, device tree, ACPI, or maybe some platform data structure that was passed in by the bootloader.
is that, okay, so Dustin says there's two choices. One is a platform driver that basically knows the answer and calls for each one, or an ACPI.
Or some kind of platform description, device tree or ACPI.
Are those in place for SFP and QSFP? Are there any actual instances of that?
Yeah.
Awesome. You'll have to tell me, you're into that, right? I mean, you were a while ago. Okay, so you have to tell me more about that.
Time check.
Oh,
So we've hit the hour mark, and it sounds like things are still going swimmingly.
well, it's like pulling taffy, but
So I think what we'll do is go another half an hour in both sessions, and then we will definitely take a break.
I want to ask a question. We've been talking like there's nothing between the SFP cage and the control plane processor. But in a switch, there's some Broadcom silicon, a Trident, or something like that in the middle. And how does that play into Dom and all of his friends?
okay. So the question was, what role does the Broadcom switch have in all this, and why haven't I talked about it? And if I get this wrong, go ahead and tell me. But this amazed me when I worked it through. But it's not involved. It's not involved at all. I don't even have a license for the Broadcom switch in the Broadcom ASIC in the switches I'm using. The I2C bus is connected through to the switch CPU, not the ASIC. So actually, without that ASIC doing anything useful at all, I just power on the switch, fire up the NOS, and I can start talking to those. And all it is I2C accesses to those EEPROMs, read and write. So unless I got that wrong, I don't care about that switch. I don't need any license for it. It's not a very useful switch, but it turns out it's everything I need.
Thanks.
I have two pieces of information to add if you want them.
Okay?
One is there are switches that have the I2C
So if I may, I would guess then,
Problematic because the CPU is the one that really cares about most of that stuff.
but I would guess then there's an I2C driver
Yeah,
in the
a lot of
kernel
it goes through user space, usually with like a Broadcom SDK or a lot
through
of
user space.
most of the SDKs talk to the ASIC from user space.
Okay, so he says in the case where it goes through the switch, so the I2C is on the switch ASIC, it all goes through user space.
Which is problematic because you can't, it's harder to make a sysfs interface for that. Not impossible, but harder.
Okay.
That's one piece of information. The other piece of information is you said the ASIC's not involved, and that's true only if you don't care if it switches packets, right? Like the ASIC is totally involved with like bringing the link up, like the fact that a particular type of object is plugged in is very important for that ASIC and all of the support software to know. So the loop does get closed. Like
So-
you can only make that statement if you don't care about switching
Right,
packets.
right. So Dustin makes the obvious point that if you're actually going to do any networking, it's going to go through the switch, which needs to know about the device, which needs to know if it's plugged in and needs to configure it correctly. And yeah, absolutely.
Right.
So
And
I have a very limited use case which doesn't use the switch.
And I'll just point out a little bit that having a Python in between the ASIC, CPU, and SFP cage can be problematic in the same way because you don't really want that feedback loop going through user space, or at least not through a Python process. So there is some need for the kernel itself to associate the SFP cage with a netdev, and if any sort of link bring up tasks require knowledge of the SFP cage and knowledge of the SDK, OM is not exactly in the right spot to transfer that information.
So there's cases where you need kernel access to some of this data, which the driver we have actually has the Mac interface, MACC interface, to allow access to the EEPROM as well. That came from you guys. All right. What else? Okay, so you said that config is either the platform driver or an ACPI table. Device tree. Where does the device tree come from?
Usually the bootloader, or it can be built into the kernel.
It's built up as a text file.
Okay.
Another question. So, is there any coverage in terms of error handling, troubleshooting, kind of error messages in the driver that you might have?
Okay, so the question is there any error handling in the driver? There is quite a bit, but I have not reviewed it carefully to make sure every possible call is error handled. So a lot of them are. In a lot of cases, it'll report the correct error, and it'll propagate up correctly, and so on.
Do you mean errors like you try to access the cable and it returns a read error, or do you mean like the voltage is way too high kind of error?
Well, voltage is high is SFP data, but I'm saying like the driver handle like I2C error.
Yeah,
Like
So read and write
the
errors.
device get hung.
yeah. Yeah, every time it allocates memory, it checks to see if it's exceeded and has a exit. All of the exits that where it allocated some memory that hasn't yet been put in the right place, it'll jump out and say free the memory before it gets out.
Right. And
It's
if I see the kernel message and say, yeah, this error happens, I can trace it back. Those type of traceability kind of
the debug messages. You mean kernel debug messages, for instance?
debug messages.
They're not nearly as carefully placed, and the driver writer would need to decide, are they where you want. I mean, as a driver writer, I have put some more in and took some out and moved them around. But the error codes, the actual proper handling of real errors, like you called I2C, and it didn't, it gave you back an error code. That all came from production code from Cumulus, and I didn't take it out on purpose, but I wasn't careful about making sure every change I made propagated it correctly. So my driver is not yet hardened and production ready, but it's based on a hardened production ready driver. Okay. They built good code. I just mangled it. What else? What else is on my list here? Interrupt handling. Do you think we can do the interrupts? Maybe EdgeCore can help with this. Can I get interrupts from the hardware, like Dustin says? And
Anything's possible, it's just software.
so how would you get it all the way to the user? Would that just be a
Typically, there's like a file handle you can open in SysFS, register for.
socket?
It's
Just a
like-
file handle? And
Yeah, you basically register for events there and do a blocking read or a select or something on it. Eventually, it'll return and you can go see what it was.
okay. So Dustin suggests to use the standard Linux interfaces, which is, of course, always a good idea. Brandon, have you looked at interrupts? Can we get interrupt into the driver when the
The
CPU?
driver is, so to speak, in the user space, right?
No, it's not. The driver's in the kernel. Can we get interrupts so when the device gets plugged in, we get an interrupt from the CPLD that tells us to do something, calls out, hits a call out? Yeah. Okay.
If there's a detect pin, you could always have the CPLD hook it up to this processor IRQ.
To who?
Processor would have its interrupt vectors
Okay.
if you could hook it up, or if the processor has GPIOs, you could say that it's a GPIO which triggers an interrupt.
Okay. Do we need it? Does anybody think we care? When you pull out the device, put it back in?
It's pretty good.
Are we dancing on the head of a pin here, like nobody actually really cares? Or
Yeah, it solves a lot of your bus bandwidth issues. You don't have to keep pulling the thing to decide new cables.
okay, all right. So I'll keep it on the list of things to worry about. Oh, user space drivers. I sort of just briefly heard that a couple times. Does anybody do user space Linux drivers? Is that an alternative we should explore? Is that a better thing, a worser thing? When I talked to Dell about Open Switch, they said, oh yeah, it's a user space driver and blah, blah, blah. I went, wait, I don't understand. Anybody understand that phrase? Harder to put in SysFS, you said?
There's no standard for that, right? There's no, like you can't write an SFP driver for one system's user space and expect it to work anywhere else.
Okay, so user space drivers aren't standardized in Linux. There's
Maybe it's standardized an API or something like that to access them, but like OOM. But
that's not the way you do it, and that's not the way you do it, and that's not the way anybody else I've met does it, so let's stick to in the kernel. Okay, all right. What else? Helpful suggestions, more questions. Why didn't you do it this way? Are the cookies open? Okay, I think we'll tell our hosts that we've completed our session. Oh, no, don't do that. Steve says don't do that.
I think you should ask the question, should we convene a regularly scheduled meeting? And, once every week or once every 2 weeks or something. And then if we did convene that, to move this forward, I think that's the most logical way. In other words, start a project within a sub-project within the networking.
Or resuscitate OOM or...
I would run it as a separate, well, you could either run it under OOM or, but how many people do we think would attend? Is it worth doing? Right now, you're doing this by working individually with 2 or 3 people.
Yep.
And so it's becoming kind of self-contained. The idea would be, should we open it up to the community?
Okay, so I'll repeat the question for online, even though I don't know how to get an answer back from online, but who would participate if we called a meeting, say, once every 2 weeks to follow the progress of the driver, address specific issues, if someone has suggestions how to make it, what the SysFS names could be, then maybe I'd implement it, and 2 weeks later we could see how that works and attack the next issue or something like that.
You could ask the question, is it a good idea?
Yeah, if we did that, would that be a good idea? Who's in? Who'd actually show up?
You're talking conference call.
Conference call, yeah. No, you got to come to Mountain View every 2 weeks. Conference call, who's in? Okay, so let me Can you all send me an email so I can get you invited? Oh, well, we just send it to the OCP networking and say we're going to. I see about a dozen people are in for that.
I mean, it's a calendar, and I can get on it.
Yeah, what if you called a meeting and nobody came? It's just very disappointing.
So this would be managed through our monthly networking meeting. You know, that it's there and it's happening. You know, it would be a sub-project of that.
I just can't see without them. Don't ever let anybody watch you type. It's just not pretty. Okay. What else, Steve?
That's it.
Can I add one?
Dustin.
I've always really wanted to see someone collect more like customer use cases, like make sure what we're designing and building, you know, is good for some very specific examples of what people want to do with objects and you know, specific set of objects, specific NOS, specific use cases. And maybe if we don't have them in here in the room, we must all know at least a few people who use objects somewhere. So having a group of people who can come up with that list where, you know, I mean, I certainly have my sources for that information, but they're hopefully way more with more people. Taking advantage of that seems like a good idea for this project.
Can you give me an example just to bring it to life?
I don't know. Tell me a customer you know of. And,
Well, I was going to ask, tell me a customer you know of and something they do with the optical data.
I think I got an example here. Customer care about the link budget. The link budget between the the fiber optic link. You know, I'm going to ask. You know, your remote access to the other end. How far? You know, is it multi-mode, single mode, or it doesn't matter, or is it just AOC? I mean, that's my question, because the end user, the customer, they care about the link budget between the link, right? And if they can use your parameters ratings and figure out is it under reasonable link budget, or for the troubleshooting, if the optical link has in the middle.
I have to confess my ignorance. I'm a server operating system guy who's been asked to help the optical vendor do some operating system kind of stuff. I don't know what you mean by link budget.
Yeah, between the when you hook up the optical link, yes, in the data center in the same rack doesn't matter, it's okay, but when you distance go longer than that, right, between the two optics.
So there's a minimum power that a transmitter sends.
Exactly.
And there's a minimum required receive energy.
Okay.
The difference between those is some number of dBs of loss that you can suffer
Okay.
in the fiber plants. And that loss comes from the fiber, but it also comes from technicians who clean the jumpers on their shirt.
So that all pops off of the DOM data, right?
That's right.
All comes from the DOM data. So you can get it, and yes, the thing I was talking about for both ends of the fiber, you can get that data from both ends on this special product.
RX power matter.
Yeah, exactly.
This is one of my favorite examples because it highlights the need to have easy access to the data on both sides of the link, but you also need something to exchange the information between the two sides of the link and do the math and give you a reasonable user
Yeah, but
interface.
when you put each link together, that's the whole design for the whole optical network. So that's the optical network design guy would love to see, and also for their maintenance purpose, they want to see whether their design is solid while in the operation.
Yep.
So,
And I'll point out that people probably don't want to run a separate region just for this. It would be great if it integrated with something they're already monitoring their network with.
yeah, because this is non-intrusion. This is great. You don't need to plug into the meter and to measure the power. No. So it's live. So it's just as long as the the reading is relatively accurate.
Oh, it comes right.
That was
Yeah.
relatively accurate. So,
I think it's as good as you can get because it's coming right off of the device. Yeah.
that's great.
So for use cases, you have an inventory. And you can do an initial inventory that includes all the optical characteristics upon deployment. And then you can continue to monitor that if those operational statistics change. For instance, you can detect whether a fan is beginning to fail. You could use the system monitoring of fan speed, or you could use the temperature of the module to detect that the fan is failing. You know, so basically inventory and just monitoring.
Right.
functions.
Right. And I want to make a distinction between what you can do and what customers are doing. I'd love to hear someone say, I talked to a customer who said, you know, so I like it. Does anybody actually have a customer who's said, I'm using the temperature data off your optics to check the temperature of my switch? I'm not sure. I mean, it amazes me how many temperature sensors there are in a switch when you count all those optics especially. Okay? Is that enough? Does that capture your...
I'd like to see the list get longer, but it
Yeah.
doesn't have to happen this second.
Good point. While we're here, anybody else? Talk to customer and get, I mean, does anybody else have customer examples of using optical data?
Energy consumption.
Sorry?
Maybe we can measure the energy consumption for the fibers. I think it's a good measurement if we optimize the switch and the pressure, and then we see the energy consumption get lower. Yeah, I think it's SFP, so we need to get the information from the EEPROM.
Mm-hmm. Have you talked to any customers who raised that?
We're kind of customer, so we're.
You're Microsoft. Oh, okay. All right. You count. Okay. So, how would you do that? I'm going to.
We're not doing that, but I'm thinking about that. For example, if there's some SFPs that are not used, we can make it to a lower power mode, and then we can measure how much energy we save. Yeah. And we times the money we spend for electricity, how much money we save just for this.
Right, okay. And that's going to take an application above that figures out that link's not being.
We need to get access to the voltage or anything information on the SFP layer. Yeah.
Okay. So if you want to turn off the power on those lasers, we could turn it off from the driver,
Yeah, from the.
or we could turn it off by accessing the EEPROM.
Yeah.
Steve, do you have to know if those have different power characteristics? If I use the pin for TX disable, or if I use the EEPROM for TX disable, it's do the same thing?
Those two for TX disabled are the same.
Yeah.
But many of the modules have what's called a low power mode.
Yeah.
Okay.
Literally, it turns off receiver, clock data recovery circuits, lasers. The only thing it leaves on is the monitoring, the core CPU.
Okay.
It's monitoring that so that it can be, you can tell it to start up again.
Okay, so Jeff, who controls that? Who controls low power mode? It's hardware, right?
There's software and there's hardware switch. Hardware.
Yeah, so how would his application tell the switch, put that thing in low power mode? Is there a driver attribute? Is there a switch SAI, the switch silicon API?
Yeah, probably.
Okay, so I'm going to put down, it might be useful to have a sysfs attribute that says, put that thing in low power mode.
Yeah.
It's platform specific.
Okay, which means anybody that implements it has a special feature. Okay, what else? This is great, by the way. This is a widespread list of choices. Steve, can I be done now?
I'm done.
Okay.
I have to go.
I have discovered Coke is in the big refrigerator and cookies are in the bins over here. I think we're done. Thank you very much.